Hi, I'm Nis Jespersen, Solution Architect at Transmute. On this session, I'll talk you through how to create and use verifiable data based on strong semantics from, among other places, the UN CEFACT BSP library. So agenda-wise, I'll start out talking through what a verifiable credential is, how it is constructed, and what it is good for. Then I'll quickly recap the linked data purposes and how it links to the CEFACT semantics. I'll show the full technology stack and fitting it all together, and that would also serve as the basis of the subsequent demo. A verifiable credential is really nothing but standard JSON data with a signature added on it. You could say that data and trust travels together in the same data file. That's a good way of expressing it. More specifically, it's got a proof section, which is shown on the bottom here, which serves as the digital signature of the data above it. So what you can use that proof section for is to verify that the data on top is still the way that the issuer that created the data intended it to be. So how this file has been transported to you, whether by text message or email or copied and pasted, that doesn't matter. As long as you have the proof and the data together, you can always verify that the data truly is how the issuer intended it to be. The analogy to old-fashioned analog paper is straightforward. You have an issuer which typically has a logo pre-printed on paper contracts. You also have issuance dates, which you typically have. You have data, which is the business specific, business relevant data that needs to go on that piece of paper, which is in the credential subject. And then, like I said before, you have the signature, which maps to the analog paper-based signature. The only difference is that a cryptographic signature is, from a security perspective, much harder to fake. Here's just a simple flow of data, how data can travel between parties of a supply chain. So in this case, there's a steel manufacturer which issues a mill test report as a verifiable credential. So that's the issuance use case. That gets shared, presented to, in this case, a steel importer, which can verify that data, no matter where it's been in the meantime and how it got passed along to the steel importer, you can verify that the data indeed is how the steel manufacturer, what they tested and what the data that they signed for. Subsequently, the steel importer issues a commercial invoice for purposes, among others, to be presented to the customs authorities. So the package or the pouch of those two documents gets presented to the importing authorities, which subsequently verifies both data files against two different issuers in this case. Moving on to the linked data and semantic aspects. So semantics is the meaning of words. So consignment is, as we all know, the collection of movable goods from a consignor to a consignee, yada yada. That's all well and good, but when using it technically, it requires interpretation of the programmer that receives this data, understanding what the terms mean and fitting it into the target system. A smarter way of doing that, or at least more concise way of doing that, is by expressing the semantics with URIs. That's what linked data is all about. So if you point to the URI of consignment, which is shown here on the right, as defined by UN CEFACT, there's no ambiguity in terms of what that means. There's a clear pointer from the sender to the receiver and anyone else using these same terms about what is intended to be communicated. In terms of storing storing semantics, humans obviously store data in brains, and machines store them in knowledge graphs. I'm not going to go much deeper because I've already done a presentation of this in a previous CEFACT forum, so I'll refer to that. Let's So all in all, this is why we in the RDM2 API project have been so focused on getting these rich semantics that have been refined over decades in CEFACT and having them expressed as URIs. So on the right here, it's not so much the rendering of how things are described with human words. It's the URI on top that's key, and this is core to the RDM2 API methodology. Now let's talk for a minute about context. Those of you familiar with JSON LD knows that context is an essential element. What it does is essentially map each term used in the file to a concise vocabulary, URI from a vocabulary. So we have a simplified verifiable credential on the right here, and you can see the context on top. And first because it's a verifiable credential, we have to point at the credentials context. That defines terms like verifiable credential. But underneath, I've included a reference to the traceability vocab, and that's this thing I have on the middle, which is really it's a standard under W3C CGG that where we sit together and define what are the appropriate vocabularies and terms for the various schemas that are necessary in supply chain documents, supply chain data. So because that really goes a little bit beyond just CEFACT, there are some things that are more specific and other things that are more generic, contrasted to CEFACT. And I've made a few examples of that. So if the verifiable credential on the screen here is based on the DCSA schema for transport documents. So the transport document and shipping instruction, those are terms that are defined by DCSA, and therefore, for that reason, I'm referencing the DCSA specs for those terms. In the middle, if you will, you have the well-known cargo items, transport equipment, utilized transport equipment, many others, shipper and consignee. Those are terms that are defined under UN CEFACT. So obviously, I'm pointing from the context. I'm pointing those terms to CEFACT, to our URIs. But then further down towards genericness, you have elements or definitions that are even broader, that aren't just limited to supply chain, trade and transport, but really the whole world, if you will. So terms like organization and address, there's no reason to not go further down. You should generally gravitate downwards towards a more generic term, because then you are interoperable with a larger group of people understanding what you're expressing. So on the schema that I'm using, I have my suggestion on how to do that, and more work is needed, and I strongly encourage collaboration and involvement in the traceability vocab community. So this slide is my everything in one, which shows this modern technology stack and how it all fits together. So if we start from the top, there's a business layer. In this case, I'm choosing a shipper requesting a bill of lading from a carrier. So the shipper sends a shipping instruction and gets a bill of lading back. Underneath, you have the trust layer, as I call it, which is based on the decentralized identifier and verifiable credential standards that allows the shipper to issue the shipping instruction, which can then subsequently be verified by the carrier. And on the reverse, the carrier issues the bill of lading, which can be verified by the shipper, or for that matter, anyone else receiving the bill of lading data. One level further down, on the process side, you have organizations like DCSA and IATA who define specific processes and use cases and the APIs that support them. And as part of those APIs, you have request schemas and response schemas that support them. One level further down is the JSON LD overlay, which defines the terms of those schemas by use of the context element, pointing, like I just said before, to the various places where these terms are defined. All right, and now it's demo time. Let's see how this all works in reality. So for the demo, I've split my screen in two here. And what we're going to do is we're going to issue a bill of lading on the left side of the screen, representing a carrier, issuing and sending a bill of lading to the right side of the screen, which represents a shipper, receiving and verifying that bill of lading, that data that was received. So let's start out here. This is our, I'll utilize our API to do the actions on the carrier side and our web application on the right hand side for the shipper. So the steps I'm going to go through is issuing, and then the latter three is for presenting or sending the data. So first things first, let's issue. So this is the input data for issuing a verifiable credential. It's what we call a credential, which is not yet verifiable. So you can see here that what I'm asking to do is build a verifiable credential. The credential subject is a transport document, which has obviously the link to our context that we talked about. Then it's got all that data that a transport document needs. And that's it. There's nothing more. Still no signature, like we talked about. That comes now when I invoke the issuance endpoint. I'll just make this a little bit bigger. So now what comes back is the same data, but at the end, there are a bunch of verification elements added. In particular, it's got an ID now that we assigned. It's got an issuer, which was the organization just doing this issuance. It's got an issuance date, which was right around now. And it's got a proof, which is the cryptographic signature that binds this data to that issuer's private key. Cool, so we have a verifiable credential now. Next step is to pass this credential to the shipper. And I'm going to do that by use of what's called a verifiable presentation, which is also part of the W3C spec, and do that with in an authentication tunnel. So the first thing I will do is reach out to the shipper's endpoint. I'm calling this available. I'm not going to go too much into details about this, but it sends back a key, which I'll then use to sign just the presentation, just this one presentation. So this call is for signing the verifiable presentation. I am giving the verifiable credential as input. I stored that in this variable. And I'm also signing with that challenge and domain that I just got from the receiver. So I'll do this. And what you'll see when this comes back is that now we have not just one signature, but two. So towards the bottom here, this was the signature of the verifiable credential we just looked at before, but it's also included in a kind of envelope or wrapper, which is that presentation is also signed. Think about this as I'm putting a signed document into an envelope, which is also signed or stamped or whatever. So I can be assured that when it hits the receiver, that envelope hasn't been opened and tampered with. That's how you should think about it. Finally, I'm taking all that stuff, or that verifiable presentation, in which I also kept in a variable, and I'm passing it to the shipper's endpoint called submissions. Excellent. So now let's switch to the shipper's side of things. So here's the shipper's organization on the Transmute platform. And if we go here to what we call the secure sharing center, we'll see that there's a pending offer, and we can see what's in it. And this is a transport document, which is indeed the one we just sent. So what I'll do, I'll just go ahead and accept that. And after I accepted it, that credential that was in the presentation envelope, if you will, is kept here. I had one from earlier today as well. So let's take a look at what that looks like. So here's the transport document with the data that was provided. We can also see the technical, the JSON LD underneath, the signature, all that stuff. And then the reason we do all this is for verification. So that's what our security tab does. And well, indeed, this verifies. And let's just take a quick look at these four. So I'll just pull up the presentation on the left side, sorry, the credential on the left side to go through these elements that we are now verifying. So activation says that the issuance date is sometime in the past, meaning that the credential has been activated. You can make credential active only in the future. The signature validates or verifies the issuer's distributed decentralized identifier. Revocation checks that after issuance, the VC has not been revoked. Revocation is an important part of the verifiable credential specification, which means that even after issuance, you can call back, you can revoke credentials at the issuer's discretion. And then finally, the actual data check, which matches the cryptographic signature with the data that it signs over. So if anything had been tampered with here, if you just added a zero on a value or whatever, this would not verify. This would falsify here. So that concludes my demonstration. We saw a bill of lading getting issued, presented by a carrier, presented to a shipper, received, stored, and verified. And that concludes my both demo and presentation. So without further ado, let's switch to questions. And before opening up the mic, let me just thank you very much for your time, everyone. It's been a pleasure. Yeah, thank you.